Okay, so this is Higher Chemistry Unit 2. It is the Oxidation of Food sections, and we're going to start talking about aldehydes and ketones. Okay, so as a recap from before, we need to know how to classify our alcohols. So alcohols can be classified into primary, secondary, or tertiary alcohol, and that is based on where the functional group is, so where the hydroxyl group is in the alcohol. So following on to aldehydes, we need to know that primary alcohols oxidize into aldehydes. Okay, remember primary alcohols, the hydroxyl group is on the end carbon. Okay, so the carbon attached to the hydroxyl group is attached to one other carbon atom. So for example here we have got ethanol. Okay. So we need to know that aldehydes are their own homologous series. Okay, remember, homologous series is a group of compounds that are represented by the same general formula and have similar chemical properties. And these similar chemical properties are all caused by the functional group. In your aldehydes case, the functional group is this part here. Okay, so this part here is called your carbonyl group. There's carbonyl group there. Okay, in aldehydes, the carbonyl group is always at the end of the chain or the end of the molecule, which means it always has a hydrogen attached to the carbon also. So you're going to get C, double bond to your oxygen, and then a bond to your hydrogen. Okay, so many of your aldehyde molecules are used in flavor and aroma. Okay, and very similar to your ester molecules. Okay, so moving on, we've got different aldehydes in front of us. So all my aldehydes have an anal ending. Okay, so here first of all we've got one carbon atom. This is methanol. And look, your carbonyl group is bonded to the same carbon as another hydrogen. Here we've got two carbons. This is ethanol. And again, carbonyl group is bonded to a carbon with another hydrogen on it. And remember, this is called the carbonyl group. Down here, we've got three carbon atoms. It's going to be propanol. And last but not least, down here, we've got 1, 2, 3, 4 carbon atoms. It's going to be butanol. Okay, so remember, aldehydes are produced by primary alcohols oxidizing. Okay. Examples then. Let's do some branched ones. So, looking at this, we have got 1, 2, 3, carbonyl group, hydrogen, and we'll do a CH3 here. The rest of these are hydrogens. So here, your functional group is on the end carbon atom. Remember, we want the functional group to be on the smallest number of carbons. So we're going to number it 1, 2, 3. We've got 3 carbons in our longest chain, so it's going to be propanol. We've got 1 branch on carbon 2, and we have got 1 carbon in that branch, so it's going to be 2-methyl propanol. Another example then, let's do 4 carbon atoms, methyl branch, and a methyl branch. Okay, so now looking at this, we have 4 carbon atoms in the longest chain, so it's going to be butanol. We are going to number it from the functional group, so remember the functional group is this carbonyl group, so it's going to be 1, 2, 3, 4. I have got 2 branches on carbon 3, so it's going to be 3, 3 dashed. 2, I need a prefix, so it's going to be di. And I have 1 carbon in each branch, so it's going to be dimethyl butanol. 3,3-dimethyl-butanol. Okay, so a little recap. Aldehydes are an example of a homologous series. They are produced by the oxidation of primary alcohols. Okay, they have a carbonyl functional group, and you can identify them by the carbonyl, so the double bond O, next to a hydrogen on the same carbon. Okay, moving on then, we are going to move on to our ketones. So our ketones are very, very similar to our aldehydes, except your carbonyl functional group is in the middle of the chain. Okay, so secondary alcohols now oxidize to produce ketones, and remember, aldehydes are primary, ketones are secondary. Okay, so secondary alcohols oxidize to produce ketones, and they are another form of a homologous series, except the carbonyl group is in the middle of the molecule. So it's not on any of the end carbons. That is the only difference between aldehydes and ketones. Okay, they are represented by the same general formula as your aldehydes, CnH2nO. And here we've got 1, 2, 3, propanone. Okay, so we've got propanone. So, looking at these then, because your functional group is in the middle of a molecule, you have to say where that functional group is. So first of all, because we've got 3 carbons here, and my carbonyl group has to be in the middle of the molecule, here we're going to have propanone. Why is it not propan-2-on? Because you can't get anything other than propan-2-on. Okay, because it has to be in the center. It has to be in the middle of the molecule, and there's only 1 carbon in the middle of the molecule. All your ketones have an -one ending. That's how you can identify them. Okay, here we've got 4 carbons, so it's going to be butan 2-on, because we're going to count 1, 2, 3, 4. I have my functional group on carbon 2. Here we've got 1, 2, 3, 4, 5. So it's going to be pentan 2-on. Okay, and last but not least, remember functional group is on the smallest number of carbons. We're going to count 1, 2, 3, 4, 5, 6. It's going to be hexan. So on carbon 2, 2-on. Hexan 2-on. Okay, so now because my functional group is in the middle of the carbon atom, the middle of the molecule, then we have to then say where my functional group, what carbon is my functional group on. Okay, on to some branched examples then. So for example, let's do CH3, CH3, CH3. There we go, something like this. Okay, so looking at this then, we want the functional group, the carbonyl group, on the smallest number of carbons. So we're going to count 1, 2, 3, 4. Okay, so this is going to be butan 2-on. And then we have got 2 branches, both on carbon 3. So it's going to be 3, 3, 2 branches, we need a prefix, di. How many carbon atoms do we have in each one? Methyl, 3,3-dimethyl butan 2-on. Okay. So, oxidation of alcohols then. This is where we start to use our aldehydes and ketones. So, we need to know that the oxidation is an increase in the oxygen to hydrogen ratio, and that a reduction is a decrease in the oxygen to hydrogen ratio. So when you oxidize something, you're increasing this ratio, okay? Whereas if you're reducing it, you're decreasing it. If you're reducing the molecule, you're decreasing the oxygen to hydrogen ratio. So looking at this, okay, so we know you get primary, secondary and tertiary alcohols. And from the last little part of the lesson, we know that primary alcohols oxidize into aldehydes. Okay, from that, my aldehyde can be oxidized again into a carboxylic acid. Okay, so we go primary alcohol, aldehyde, carboxylic acid. The next one is our secondary alcohol. These can then oxidize into your ketones that we've just done, but these can't oxidize any further because my carbonyl is in the middle of the group, or the middle of the molecule. And last but not least, we have a tertiary alcohol. Tertiary alcohols cannot be oxidized at all. Okay, so primary alcohol oxidizes to an aldehyde and then further to a carboxylic acid. Secondary alcohol oxidizes to a ketone and no further, whereas tertiary alcohol cannot be oxidized again. Okay, so what are we going to use in order to oxidize these? Okay, we are going to need to use oxidizing agents. So remember, from our redox, oxidizing agents are a substance that causes something else to be oxidized, therefore themselves are reduced. Okay, so examples of these then that you need to know. So oxidizing a primary alcohol into an aldehyde or a secondary alcohol into a ketone, you could use hot copper 2 oxide. This forms a brown solid. Or acidified dichromate solution, and this goes from bright orange, like really bright orange, to green. Okay, so going through your first step, your first oxidation, you can use hot copper 2 oxide or acidified dichromate solution. Okay, so example here then, we've got propan 1-ol. This goes to propanal, your aldehyde, and then this can be further oxidized to your carboxylic acid, propanoic acid. Okay. In example 2, here we have got butan 2-ol, so a secondary alcohol. This is then oxidized into a ketone, which is butan 2-one. Okay, so primary alcohol goes to aldehyde, then carboxylic acid. Secondary alcohol goes to a ketone, then no further. Tertiary alcohol does not get oxidized at all. So looking at this, how could you tell the difference between an aldehyde and a ketone? So both of these, your primary and your secondary alcohols, are going to react with an oxidizing agent, but how can you tell if it's going to be an aldehyde or a ketone? So this is when we use different oxidizing agents to differentiate the difference between the aldehydes and ketones. So looking at these, we have got new ones. So we've got failing solution, and it looks like this. So you start a blue colour, and in the presence of an aldehyde, it turns brick red. Okay, so it's a kind of orangey, dark orangey, reddy colour. Another one we could use in the presence of an aldehyde is Tollens reagent. It goes from a clear, colourless solution to a silver mirror. Okay, so clear and colourless, this is what it starts off as. In the presence of an aldehyde, we are going to get a silver mirror. Okay, in the presence of a ketone, there will be no colour change. So aldehyde, you're going to get a colour change. Sorry, do that again. So aldehyde, you're going to get a colour change. Ketone, you're not. No colour change. Okay, so we can test that using feeling solution, Tollens reagent, or again we can use the acidified dichromate, and that goes from an orange colour to a green colour. Okay, so a recap of that, we can start off with a primary alcohol, secondary alcohol, or a tertiary alcohol. Okay, this can be further oxidized into an aldehyde. And how do we do that? What do we use? We could use hot copper oxide, put it in red, hot copper 2 oxide, or acidified dichromate. Okay, following on from my aldehyde then, I'm going to get a carboxylic acid. And how do I know, or how can I tell the difference, or how do I oxidize that? I'm going to use either feeling solution, you can use Tollens reagent, or you can use, again, acidified dichromate. Okay, looking at our secondary alcohol. Using these same oxidizing agents, you could get a ketone, but if you try to oxidize it further with either feelings, Tollens, or acidified dichromate, you're going to have no change because it cannot be oxidized further. Whereas a tertiary alcohol cannot be oxidized at all.